So as you may have guessed by looking at the screen, today's lesson is about circles and circle geometry more specifically. So give me a feel for how you feel about circle geometry, kind of with the thumbs up, thumbs down, exclamation marks. Tell me how you feel about circles. I want to know how you feel about circle geometry at the moment. Rosario says, a scene from a horror movie. However, oh, there's lots of tears.
No, that's not good.
Okay, all right. Now's your chance, guys. Let me feel your pain or feel your love for the subject. I mean, this particular topic. Okay. So what we're going to do today is we're going to try and reintroduce you to this topic of circles, and we're going to start slowly. We're just going to build up our base knowledge, and then if there's time, we will get to sort of what an exam question looks like. But when I think of circle geometry, there's a couple of basic facts that we need to have in our brains to use, and then there's the visual part where we have to recognize those facts in a visual space. And so that's what I want to spend some time doing today. Now, when I think of circle geometry, and I haven't thought about circle geometry for a while, I always go back to thinking about the facts in three big groups. So group one is circles and the center. The second group is circles, and cyclic quads. Cyclic quads. And then the third, like kind of section is circles and tangents. So when we kind of have to get our base knowledge about circles, we have to spend some time understanding the facts specifically about these kind of areas. So I'm just wondering, does that make sense to you? Give you a thumbs up if that grouping makes sense to you, a thumbs down if it feels a bit like, huh? Why would group the theorems into three parts like that? So when we start the questions now, I'm going to ask you to identify which of the three subsections you think this question relates to. So there's these three sections. There's circles in the center, there's circles and cyclic quads, and circles and tangents. So let's go and look at the very first question for today. What do you think, which of the three sections do you think this deals with? Let me know in the chat. So question one, what do you think this question deals with? Which section does it deal with? Section one. Okay, now, within section one, there are theorems. There are a couple of different theorems. I want you to put in the chat which theorem you think is involved here. So I see Hariva has said the one that is relevant there. I want to see some other suggestions. And I'd like people to write the answer if you know the answer to what X is. So you have to find X. Tell me what X is, and then if you tell me the reason, then extra bonus points. Oh, Tandowetu Nawazi, I like what I'm seeing. Hariva, I like what I'm seeing. What is the X value going to be? Sibogonke, I like what I'm seeing. What value are we going to get? Jabu, let's have a look. Jabu says 62. Jabu, I agree with you. So it's 62 because the angle at the center is twice the angle at the circumference. And so the way we write that is angle at center equals twice angle at circumference. And x would be 62 degrees. It's often sort of thought of as the arrowhead shape. And you can see how basically you make the angle at the center, and then you make an angle at the circumference, and the one at the circumference is going to be smaller. Okay, so let's move on to a second question. I want you to first identify which of the 3 sections is this question related to. So put that in the chat, and then tell me what X and Y is. Or if you'd like, you can raise your hand and you can talk me through it. So let's have a look in the chat here. Second section. A lot of people, Zia said second section. William said second. Beyonce. I agree with you that the second group of theorems is involved because I see something called a cyclic quad. But you know what? I also see the center of the circle. And so I think it's the group 1 and group 2 of theorems is going to be involved here. I don't see any tangents. So tangents aren't involved. Okay, so we now need to think what theorems within those groups are going to be relevant in this case. And I want you to find those answers for me now. I think finding X would be, in fact, who wants to come online? I want to hear a human voice. Put your hands up and tell me how you would find X. What are the steps? And we'll go from there. Could you unmute Amukalani, Lebo? That would be awesome.
So,
okay, let me please unmute on the side.
Can you hear me?
Loud and clear. Go ahead.
So I just wanted to ask if you could go back to the first one because I lost connection.
Okay, so the first one's answer is just 62 degrees.
Oh, okay. I just wanted to see if I was right. So thank you.
No worries. Any ideas on X and Y? There we go. Jabulani's raised his hand. So do you want to unmute Jabulani Level? That would be awesome.
Hi, sir.
Hey, how's it going?
Next, sir. So first, you'll have to calculate Y.
Okay, how did you figure out Y?
It's the angle at center is 2 times angle at the circumference.
I agree, absolutely. But it's like a funny looking shape, isn't it? Hey, it's like it's a sort of the shape that students struggle to see the most. There's 2 ways of doing this one, but this, I like the way you're doing it. So what's Y?
Y, it's 122.
122, and the reason is angle at center is twice angle at circumference. Excuse my writing here. Okay, now I agree with you, like you are winning at life, Jabulani. Now tell me, how do I get X?
X, you're gonna use the X is going to be, you're gonna use the, which theorem is it? I forgot the theorem, but it's
fine. Give me the number then. What do you think the number is? I'll help you with the reason.
Okay, the answer for X is going to be 58. The reason is opposite angles of cyclic quad.
Yeah, exactly right. So the opposite angles of a cyclic quad always add up to 180 degrees. So basically what Jabulani has seen is that this one, the green one and the red one add up to 180. And since we know what the Y is, we go 180 minus 122 and we get 58. And the reason is opposite angles cyclic quad. So, apologies. So opposite angles cyclic quad. And that is perfectly right. Now, that's not the only way to do it, though. There are other ways to do it. Another way of doing it could be to say, what is this angle over here? And this angle over here, because it's angle in revolution, you go 244 minus 360. So 244 minus 360 is going to be 244. My brain is a bit 116. And then if you find that out, you can figure out that X is going to be 58. And then go from X being 58 to work out what Y is, which is going to be 122. Using a very similar argument. Okay. So we've already done a question. Oh, how I got X. Okay. So Mike, what we did was, this is something called a cyclic quad. Okay. So if we look at what Jabulani said originally, the first step was to get that this was 122. And now we use the fact that this thing is a cyclic quad. And so the X and Y are opposite angles in a cyclic quad, which means they always add up to 180. And that's why this one over here and this one here, it means basically X has to be 58. Does that help you, Mike? So if I think of the same idea applies somewhere else in the question, so this angle over here and this angle over here would also add up to 180. It's not relevant right now, but they're also opposite angles in a cyclic quad. So a really key fact that we need to learn about circles, whenever we have this type of situation, so we have a circle and then we have a cyclic quad. Now a cyclic quad is just a quadrilateral where all four vertices are on the edge of a circle. Now, the opposite angles would literally be like these two. Those will always add up to 180 because they're opposite angles, and we can use that to help us in arguments. Okay. All right, let's move on to our next question. We'll be doing nicely today. Told you, circles, you just have to spend some quality time together. Okay, well, I want to know, what is the value of X in this question? And the reason. You can put this in the chat. A bit of a sneaky one. Well, it's not that sneaky, but. You can do it. I want to see it. And if there's a little bit of a sneaky catch in this one. I'm going to catch you guys. So it's got to do with the shape. So it's almost like the reverse arrowhead. This is not a cyclic quad. And Jongo, you are on fire. So if you look at this point over here, this is not on the edge of the circle. So this is not a cyclic quad. Teachers often check this one. So actually what this is dealing with is it's dealing with the angle at this. So if you focus on this long bit and you imagine it makes an angle at the center, which is this angle, and then it makes an angle at the circumference, which is that angle. That's my little tip to help you guys. It's like an arrowhead that's pointing the other way. But in Jongo, you've given us good stuff. See if you can work. Otherwise, maybe somebody can come online, raise their hand and explain how we do this one. There's a couple of answers I like. Awami's got answers. Lesego, Teddy's got answers. I want to know, someone needs to come and explain what they're doing to me before I work it out. Okay, Teddy, let's go to you. Level, can we unmute Teddy?
Yes, Mr. Yes.
Awesome. Teddy, talk me through what you were doing.
Sir.
Hey.
Good afternoon, sir. Okay, first of all, X is an obtuse angle. You can see that.
Yes, absolutely. So it can't be less than 90. Exactly.
Yes. Yeah. So we have to work out first the revolutional angle,
Love it.
which is the O part. So we say
Okay.
260 minus 110, and that gives us 250.
And
And
the
then
reason
we know
we'll just
that,
say revolution, right? So that's
yes,
our
yes.
reason. Yeah. And then
we know that the angle at the center is 2 times angle at the circumference. So we'll divide that by 2.
perfect. So X is 125. Did you get that?
Yes, sir. Yes, sir.
And then we just say angle at center equals twice angle at. Now that shape is a little bit sneaky, but the way to spot it is that the center is not, the fourth vertex is not on the cyclic, it's not on the circle, it's on the center, which gives you that hint. So you should get X is 125. And that makes sense because it, like we're saying, it's an obtuse angle. Love it. Love, love it, love it. Well done, Teddy. Just give me a thumbs up if you're feeling okay with this. Thumbs down if I lost you there. That was a tricky one. Okay. All right. Awesome. So let's move on to obtuse angles. So Mike, obtuse angles are just angles that are bigger than 90. So if you think of like an angle is made up of 2 arms, this would be a right angle. This would be an acute angle. It's like, we say it's cute because it's small. Well, it's not the main reason, but that's what I say to my students. And then an obtuse angle looks like it's bending over backwards, like it's gone to the beach. So something like that. You can see how big it is. It's bigger. It's gone past 90 because it's leaning backwards. So I hope that helps. Okay, next question. I want to know which group of theorems is this question involved with? And tell me, and then after you've told me what group it's involved with, I want to know what X, Y, and Z are. Akonya, I agree. It's group 2, cyclic quads. Cyclic quads. So now you have to think, okay, in the group of cyclic quads, some of you probably know there's a theorem that deals with the exterior angle, but you've also got good old-fashioned straight lines that are in play. And then you've also got opposite angles, and they all are, you know, those ideas, those fact families are going to be helpful for you. Tanduwetu, I think using that to find X would be awesome. And I agree with Hariva that Y looks like it should be 90. So I'm going to give you some time to do that. And then when I see the answers in the chat, I'll write up my solution. Keep those answers coming. In Njongo, I agree. Z, you look like you're on the right track there. So Z, and we just put angles on straight line, and then X, exterior angle, cyclic quad, and then Y. There's a couple of ways we could get to Y, but I think opposite angles, side. Oh, why do I keep forgetting my C? Cyclic quad. And we are all winning. Okay, and if I look at the chat, I see lots of good answers coming in. And the other thing that I want you to start to kind of remember is that in this section, you get a mark for your answer, but you also get a mark for the reason. And so you need to, when you are, unless specifically it's like one mark and it just says give the answer without a reason, you generally have to provide the evidence or the fact that you're using. Okay. Chandawetu, let's go to your question. Do you want to unmute Level? Thanks.
Good afternoon, sir, and everyone else. Sir, I just wanted to ask to find y, if you instead used the sum of a quadrilateral,
Yes.
which is 360 minus to find y, is it still okay?
Perfect. So this is where geometry has a couple of ways to do it. And you're just using the fact that a quadrilateral always adds to 360, like the same way a triangle always adds to 180. It's perfect.
Yes.
Absolutely perfect. Awesome. Okay, now let's have a look at something that's a little not different, but I want to first ask you, which group of theorems does this question belong to? Or which groups, if there's more than one group? And then we're going to talk through the question. I don't think it's group 3, because group 3 would involve tangents. And I don't see a tangent. Like a tangent is a line that touches a circle in one place like that. That's when we get the group, circles and tangents, but I don't see a tangent. I don't see cyclic quads. All I see is the center of the circle. And so I think it's just going to be group 1 of facts. But there could be other stuff inside that I've missed. But for now, I don't see cyclic quads. I don't see tangents, unless I've missed something. Yeah. Amukalani, what's your question?
So I think we see the diameter there, and then if we want, I think we can make we can draw a line from QO to make it another radius. And then, yeah.
Okay, I see where you're going. Okay, let's talk through this question together. So it says here, O is the center of the circle. So we've got that. Then it says SP is 100 millimeters. Now, SP is just this diameter. Okay, so that's SP. Maybe we should even write it in because it might be helpful. So we can go like this is 100. It says that OT is perpendicular to QP. So OT is perpendicular to QP, which is that. And then it says that OT is this bit, is 40, which is that bit there. Calculate the length of QP, which is this red bit down here. So I would like some suggestions as to what theorems, we know it's from group 1, from circles in the center. What theorem might be helpful to us? I want to know from the class, if anybody has an idea, is there another theorem that you've seen before that might come in handy here? Okay, so
We have a hand from Owen.
Yeah, let's go to Awami.
Hello, sir.
Hey. What
Sir,
could
I think we first have to state that these triangles are similar.
Okay.
And then we have to find TP. And since they're similar, QT is equals to TP. Therefore, if you add them together, you get QP.
Okay. I'm following most of what you're doing, but okay, I like what you're saying. You're saying get QT And because these triangles are going to be the same or something, you can sort of double whatever. If you get one of them, you can get both of them type of thing. That's what I was hearing.
Yes, sir.
Is there a theorem that you remember that deals with a line going from the center perpendicular to a chord? Can you remember that theorem?
I can vaguely remember it, sir.
Yeah. So it basically says that the line from the center perpendicular to the chord will cut the chord in half. So that's what you're talking about. You're saying, look, if I could get this one over here, I can just double it because of that theorem. But I think we need to figure out what OP is. Can somebody put in the chat what OP is? So I'm just going to watch the chat. What is OP going to be equal to? It's 50. And the reason is, well, you can just say it's the diameter, or you can say the diameter equals 2 radiuses. It's just halving the diameter, or radii probably is the better way to say it. Agreed. So if you know, then instead of that being 100, this is 50, then what we're going to do is we're going to find TP. And I saw in the chat already, some students had said use Pythagoras. So using Pythagoras, I think that TP is going to be 30 millimeters. And we say Pythagoras because I recognized Pythagoras as the 3, 4, 5 triangle. Now I want to know if this is 30, what is my final answer going to be? What is QP going to be? Okay, so I see the answers flooding in. So QP is going to be 60, but we still need to give another reason. And the reason it's 60 is because we know that line from center, basically we have line from center. Oh, come on, computer move. Line from center perpendicular to the chord. And when we have that, we know that it's going to cut this into 2 equal halves. All right. Give me a thumbs up if you feel okay with that. Give me a thumbs down if you feel a bit unsure or where you at this stage. Fantastic. Okay, so what we need to do now is we need to stand up and we need to give our body some oxygen. And I want you to turn on your cameras and we are going to stretch. So up we get. Doesn't matter that ESCOM turned the lights off. We were going to shine brightly. Let's go. Oh,
join us in the stretch, guys. Give
I
your
want to see your lovely
body a
faces.
break.
Oh, it feels good. I hear a lot of clicking.
Turn on your cameras. We love to see your faces.
Let's do it. Look at those happy smiles.
Shout
Circles.
out to
They don't get us down.
Akona.
They don't get us down. We're showing circles.
Shout out to Mbusa and Tandaletu. Shout out to William.
There we go. Oh, goodness gracious. I think we should maybe extend the stretch to like.
Shout out to Zanele. Yes, yes. It's very much needed.
It is. Like, I feel like everyone should get every half an hour a mandatory 30-second to a minute stretch break, right? Just like we put it in the government legislation from next year's, I don't know, whatever.
Legalize it.
All right. So now it's time for a brain break. And the brain break is Christmas themed today because the shops are starting to fill up with Christmas stuff. So I want to know what a Christmas tree plus a bauble plus a teddy in a box is equal to. So Tanda, where to? You've got the Christmas tree in your. Now, what about the rest of this? Njongo, is that your final answer? I don't even know what the answer is yet. I have to still work it out. I agree, though, that Christmas tree is 5, because that's the only way you're going to get to 10. And I agree that this is 7. Okay. And so this does have to be 13. So the final answer is 5 plus 13 plus 7, which is 25. Look at that. So I think, Njongo, I think you were fast off the mark there. Teddy, you're not far behind. And William just behind that. Cool. I'll try and keep the themed brain breaks coming as we head into the festive season. Okay. So take another deep breath. Stand up and stretch if you need to. And we're going to go into the second session of our circle journey for today. Well done, Mikhail. I see you got the answer there too. Okay, so let's go on to the next type of question. Let's leave that one out. Okay. This question, I'm not going to ask you to name what groups of theorems are involved anymore, because I think you can see here's the center of the circle. So group 1 might be involved. And here is a cyclic quad. And so group 2 will be involved. I want you to try and find me X, Y, and Z with full reasons. And I'm going to give you 2 minutes to do that. And then once you've finished, if you feel like you can share how you did it, you can raise your hand and you can let us know. But off we go. See if you can fly solo on this one. And if you've got questions, you can just raise your hand as well. Okay, so I see Hariva has a answer for the first one. Looking pretty good to me. Let's keep going for Y and Z. Who thinks they know how to find X, Y, and Z?
We have a hand from Tandale too, Mr. Ace.
Aha, Tanda, where to? What do you, where to? Let us know. How did you do this one?
Okay, so firstly, I started off with P1 rather.
Yes.
is equal to angle Z, and that
Angle
is
Z.
120. That's tan chord.
Aha, but here's the thing, Tanda, where to? I don't see a tangent. Tangent is group 3. So this looks a little bit like a tangent, but actually it's just a line it's called a secant, actually. The fancy word is a secant because it cuts the circle in 2 places. But I totally get what you were thinking because it looks a bit like a windsurfer.
Yes.
But because there's no explicit tangent, we can't use that theorem in this one. But thank you very much. That was super helpful as well, because there were many students who would have been thinking that.
Yes. And then, sir, may I say the answer of y?
Yes.
For
What did
y?
you get from y?
I got y is 100. Oh, no. Y is 90 degrees and it's an angle in a semicircle.
Perfect. Yes. So y is 90. So we'll go angle, angle, singular,
Yes.
angle in semicircle. Okay, so y is taken care of. Thank you so much, Thandawetu. I'm going to open it up for the next two to someone else, but you are spot on. Who wants to have a go at x and z? Who wants to have a go at x or z? Njongo agrees y is 90 with diameter. William, let's go to you. Let's unmute William.
Hello, sir.
Hey.
Sir, for x,
Yes.
120 degrees because of angle P1, which is the exterior angle of a cyclic quad.
Yeah, so exterior angle cyclic quad. I completely agree with you. So this is 120. We've said already that that was 90. Now, what about any ideas to get to Z?
Sir, because there's a triangle PQS, I decided
Yes.
to angles in a triangle are supplementary. So
Perfect.
Z is 90 degrees.
Okay, but here's the problem. You on the right
Oh, no,
track, but there's
yes,
also two angles.
Yes, I understand. Yeah, I can see my mistakes, sir.
Perfect. Any ideas? Where would you start to correct it from now? I'll give you a hint. If you could you find this one over here? What do you think that is?
Well, sir, I think that angle P1 is not a complete angle.
Yes.
Angle P itself. So if you could make angle P2, that would be 20 degrees because of angles on a straight line.
Yeah, it would be 60 degrees. Yeah.
Yes,
Yeah.
sorry, 60
Perfect.
degrees. And then
So
if that's
SQ 60, and we'll put angles on straight line. Yes. Okay. And now, what's the last one going to be? Z.
Then Z would be 150 degrees.
So we go 180 minus 60 minus 90. And because we're taking away the other ones, hey, whatever's left is going to be the Z. So I would get I get 30. Would you get 30? So because you take away, you're basically trying to find what Z is. And so you take away 180 minus 60 minus 90, you get 30.
No. Yes, I understand.
And so the reason we would say is just the sum of angles in a triangle. Loving it. Okay, so that was a bit harder, huh? Definitely going up a notch. But I can see that it's also, we're learning as we go. Are there any more questions about how I got 30? So y is 90. Okay, so there's a theorem. There's a question that says, how is y 90? So there's a theorem that says the angle in a semicircle is 90. So if you have a diameter, it goes through the center of the circle. When that diameter subtends an angle at the circumference, that angle will always be 90. And so that's called the theorem angle in a semicircle. And so that's how we knew it's 90. It's theorem 3 normally on most lists. Okay, then another question, Mike has asked, how do you identify a cyclic quad? A cyclic quad is a quadrilateral where each of the vertices is on the edge of the circumference of the circle. So PQ, PQRS, this is a cyclic quad because these are the points, the vertices that are on the circumference. Now, the exterior angle of a cyclic quad is formed when you take a straight line inside the cyclic quad and just extend it. And so this is the exterior angle in a cyclic quad is always equal to the interior opposite. So it's inside and opposite, which is that one there. Okay, then Hariva's asked, why doesn't the whole of Q equal 90? Because the theorem talks about the angle that is being subtended at the circumference. And so we have to always go back to there. So it's just that bit there. Sorry, it's looking a bit like a crime scene now because of my small monitor. So it's just that bit that the theorem deals with. Okay.
Mr. S, I think there's a question from Njongo.
Okay, Njongo, go ahead. Unmute yourself and we can talk some more.
So
yes,
I was actually gonna ask about the how you got the X and
the X. Go ahead. Yeah.
And you say it's like it's an extended angle of a cyclic quad.
Exterior angle, yes. Yeah.
Exterior angle, yeah, sorry.
So, okay, let me show you the theorem in another way. So say, for example, I have a circle like this, and then I'm going to make a cyclic quad. So there is my cyclic quad. Now, we don't see any exterior angles yet, but let's say I extend this line. Then this angle is the exterior angle of a cyclic quad, and it will always be equal to the interior opposite. However, there are other relationships we can look at. So say, for example, I extend this line or produce it, then that angle over there is an exterior angle, and it will be equal to the interior opposite over here. So does that make a little bit more sense about how the exterior angle of a cyclic quad always equals the interior opposite? Okay, I'm going to assume that it did help a little bit. But yeah, so cool. Awesome. And this is just, so part of the reason circles can be tricky is that we have to get these fact families for the three groups in our head. And then once we have the shape, then we have to visually recognize them, and then we can start to use them. Okay, let's do this one. I want to know what X and Y is. Can I go down a little bit? Okay. Oh, sorry, guys. I went too far. How about that? You start with X and find me X and Y. And then I think this is going to be it for today, and we'll continue in the next lesson. Aha. I think you're getting your exterior angle theorems sorted here. Yeah, so X is 88 degrees. Exterior angle cyclic quad. And Y is going to be equal to 105. And it's going to be the same reason. Yeah. This almost becomes a bit easy, doesn't it? Okay, now we're going to finish with this one. I'm going to sneak in one more. I know I shouldn't, but this is and we're going to talk more about these types of questions in the next lesson. But you'll see here for the first time today, we have what's called a tangent. In fact, you know what? I'm going to do this one for you. We'll start in the next lesson with this. So this is a tangent, and there is a theorem that says that the angle between the tangent and the chord is equal to the angle formed at the circumference over here. And so Y is going to be 60. Yeah. So this is called the tan chord theorem. So this one over here is going to be equal to that one over there. And X, so is going to be equal to this one, because it's the same theorem, but just coming from this side. So X is 45 degrees from the tan chord theorem. And then the last thing, so again, if you've never heard of this theorem before, I don't want you to get a fright now. We'll start the next lesson at the beginning like this. But I'm just showing you kind of how this would work. And the reason would be tan chord theorem. And what's the Z going to be? So we know X is 45. We know that Y was 60. What's the Z going to be? There's actually two ways you can do this. So I think probably sum of angles in a triangle or angles on a straight line, we just go 180 minus 45 minus 60, and we get 75 degrees. And so a Z would be 75 degrees. Okay, so we're going to continue with tangents in the next lesson, but that is it for today.